Practice number 2, miscellaneous problems number 2. Problem number 7. You have to prove that integral 1 by a square plus x square dx equal to 1 by a tan inverse x by a. This is a well-known formula, but using antiderivative property you have to prove this. Antiderivative property means if you integrate this 1 by a square plus x square dx and the right hand side is 1 by a tan inverse x by a, then the antiderivative property says that if you differentiate the right hand side, you will get the integrand. That is to prove d by dx of 1 by tan inverse x by a. We have to prove that this is equal to the integrand. The integrand is 1 by a square plus x square. Very simple problem. Solution: you take d by dx of 1 by a tan inverse x by a, differentiate this. Very simple. 1 by a tan inverse x by a becomes 1 by 1 plus x by a whole square. Then you have to differentiate x by a, that is x into 1 by a constant, x becomes 1. This is a. Now this is equal to 1 by a squared, 1 by, take LCM, a squared plus x squared. Now this is a squared by a squared get cancelled, that is 1 by a squared plus x squared over. That is, if you differentiate this, you will get this. Means by antiderivative, if you integrate this, that is, this implies by antiderivative property, if you integrate 1 by a squared plus x squared with respect to x dx, you will get this one, 1 by a tan inverse x by a plus c. Solve. Problem number 8, subdivision 1. Evaluate integral y dx where y is given by x squared by a squared plus y squared by b squared equal to 1, the ellipse. This is the equation of an ellipse. Number 2, also show that the area of the ellipse is given by 4 into integral 0 to a y dx. Now come to subdivision number 1. Here we are going to evaluate integral y dx, where y is given by the equation of the ellipse x squared by a squared plus y squared by b squared equal to 1. That is, you keep y squared by b squared here, take this to the other side, x squared by a squared. That is, y squared by b squared equal to LCM a squared minus x squared. Therefore, y squared equal to b squared by a squared into a squared minus x squared. Now, therefore, y equal to b by a root of a squared minus x squared. Now, therefore, integral y dx equal to b by a integral root of a squared minus x squared dx. It's a standard formula. Say b by a x by 2 root of a squared minus x squared plus, this is x by 2, next one is a squared by 2 sin inverse x by a. Here this is equal to b by a. Now therefore integral 0 to a y dx equal to, this is subdivision number 2, b by a x by 2 root of a squared minus x squared plus a squared by 2 sin inverse x by a. This is limit 0 to a. If you want, you can put plus c. Now this is equal to b by a. Now substitute a by 2 into root of a squared minus, in the place of x, substitute a squared is 0 plus a squared by 2 sin inverse a by a. That is, a by a is sin inverse 1 minus, if we substitute 0, 0, sin inverse is 0, 0. Therefore, this is equal to b by a squared by 2, sin inverse 1 is pi by 2. That is equal to a get cancelled, pi ab by 4. This is the value of integral 0 to a y ds. We have to show that the area of the ellipse is given by 4 into 0 to a y dx. Therefore, 4 into integral 0 to a y dx equal to 4 into pi ab, that is divided by 4, that is equal to pi ab square units. This is the area of the ellipse. That's all.